In this episode, we move from simply finding possible weaknesses to understanding what is actually happening underneath them, because that is where vulnerability analysis becomes far more useful and far more credible. A scanner can tell you that something looks wrong. A report can suggest that a condition may be exploitable, and a security alert can point toward suspicious behavior. But none of those things automatically explain why the issue exists or whether it matters in the way the evidence first suggests. Debugging tools help vulnerability analysts investigate that gap between initial signal and real understanding by revealing how software, systems, applications, and network interactions behave when something goes wrong or behaves unexpectedly. For a brand new learner, the easiest way to think about debugging tools is that they help slow the system down mentally so the analyst can observe causes, effects, and relationships instead of only reacting to a finding at the surface. That matters because strong analysts do not just collect vulnerability data. They explain it, validate it, reproduce it, and connect it to real behavior in a way that supports sound defensive decisions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good starting point is understanding what debugging means in this context, because beginners sometimes imagine it as something only software developers do when code fails to run correctly. Vulnerability analysts also debug, but their goal is usually different. They are trying to understand whether a suspected weakness is real, how it behaves under certain conditions, what part of the system is involved, whether security controls are failing, and whether the observed issue can actually be triggered in a way that creates meaningful risk. That means debugging is not just about fixing a crash or reading an error. It is about examining system behavior carefully enough to explain why a vulnerability appears, whether it can be reproduced, and what the evidence says about exploitability or business impact. Once you understand that, the title makes much more sense, because debugging tools are really visibility tools that help analysts move from vague suspicion to structured technical understanding. One of the most common reasons vulnerability analysts use debugging tools is to validate scan results. Automated scanners are useful, but they do not always tell the whole truth, and a mature analyst knows that a reported issue may be accurate, partially accurate, or misleading depending on how the detection was made. A debugging process helps answer questions that the scanner alone cannot answer. Did the application actually mishandle the input, or did it simply return a response pattern that looked suspicious to the tool? Did a service actually expose sensitive behavior, or did the scan misread an environmental detail, such as a version string or error response? When analysts use debugging tools well, they can separate false positives from genuine weaknesses much more effectively. That improves the quality of remediation discussions, saves time for system owners, and builds trust in the security process because the findings are supported by observed behavior rather than by unexamined assumptions. Another major use of debugging tools is reproducing a problem consistently. A vulnerability that appears once in an unusual test may be difficult to interpret unless the analyst can make it happen again under controlled conditions. Reproducibility matters because it helps answer whether the issue depends on a random error, a narrow sequence of steps, a certain user role, a timing condition, or a deeper design flaw that will persist until fixed. Debugging tools help isolate those variables by showing what changed between success and failure, or between expected behavior and insecure behavior. When a finding can be reproduced clearly, the analyst is in a much stronger position to explain it to developers, administrators, or managers who need to understand the issue and decide how to respond. For beginners, this is a key lesson because good analysis is not only about noticing something interesting. It is about producing evidence that remains stable enough to support confident technical and business decisions. Logs are among the most important debugging resources available to vulnerability analysts, even though they often seem less exciting than flashy security tools. A log is simply a record of events, actions, errors, or system decisions, but those records can reveal exactly where a process failed, where access was granted incorrectly, which input triggered a problem, or whether a service behaved differently than expected during a test. When analysts compare logs from the operating system, application, database, web server, or authentication layer, they often gain a much clearer picture of how an issue moved through the system. A scanner might say that something appears vulnerable, but the logs can show whether the request reached the application, whether it was rejected, whether it caused an exception, or whether it triggered a backend action that should never have occurred. For a new learner, this is an important reminder that debugging is often about patient evidence reading. The truth is not always hidden in a dramatic exploit. Sometimes it is sitting quietly in records the system already generated. Network-focused debugging tools are equally important because many vulnerabilities become visible only when you can see how systems are talking to each other. A web application, an application programming interface, API, a remote service, or a client-server process may appear normal from the outside while still mishandling input, exposing too much data, or failing to enforce security boundaries in transit. Network debugging tools help analysts inspect requests, responses, timing, headers, parameters, sessions, and communication patterns to understand whether data is being handled safely. That visibility is especially useful when trying to determine whether a weakness is caused by client behavior, server logic, an intermediary service, or a breakdown in trust between components. For vulnerability work, this kind of traffic analysis helps bridge the gap between what a user sees on the screen and what the system is actually exchanging behind the scenes. Beginners should understand that many important security problems live in that hidden exchange layer, which is why network debugging is such a central part of careful analysis. Browser-based debugging tools also matter a great deal because many vulnerabilities appear in web applications that rely heavily on client-side behavior. A browser can reveal script activity, page structure, network requests, storage behavior, console errors, rendering changes, and other details that help explain why an application is behaving insecurely. This is valuable when an analyst needs to understand whether the issue is caused by unsafe user input handling, poor session management, exposed data in the page, client-side trust mistakes, or interactions between visible and hidden parts of the application. A browser debugger does not replace server-side analysis, but it often shows the front-end side of the story in a way that makes a suspected weakness much easier to understand. For new analysts, this is especially helpful because the browser is where many web security problems first become visible in human terms. It helps connect abstract vulnerability categories to real user-facing behavior, which makes the analysis more concrete and easier to explain. Process-level debugging tools become important when analysts need to understand how a program behaves internally while it is running. Instead of looking only at the network or the visible application response, these tools can show what the process is doing with memory, files, system calls, libraries, permissions, or execution flow. That visibility is useful when a weakness seems tied to how the program handles data after input has already been accepted, or when the issue involves unexpected interactions with the operating system. A process may be reading sensitive files, invoking unsafe functions, writing to protected areas, or crashing in ways that expose deeper problems than the surface behavior alone suggests. Vulnerability analysts do not always need the same level of internal detail that a software developer might want, but there are many cases where internal behavior helps explain whether a weakness is real and what part of the system is responsible. This matters because security findings are far more actionable when the analyst can say not only that the system is weak, but also which internal behavior is producing the weakness. File system and configuration monitoring tools are another valuable part of the debugging picture because vulnerabilities are often tied to changes that happen quietly in the background. A suspicious application behavior may turn out to involve an unexpected file write, a new configuration change, a modified permission, or access to a location that should not have been touched at all. Watching those changes helps the analyst understand whether the system is doing more than it appears to be doing on the surface. This becomes especially useful when testing for privilege issues, insecure defaults, weak storage behavior, or situations where one action indirectly causes another change that creates a security gap. For a beginner, the important lesson is that the visible symptom is not always the real problem. Sometimes the real issue is a hidden change in the environment that only becomes obvious when the analyst watches the supporting parts of the system closely enough to see what was altered and when it happened. Debugging tools also help analysts compare expected behavior with actual behavior, which is one of the most important habits in vulnerability work. Security issues often emerge when a system permits something it should deny, exposes something it should hide, accepts something it should reject, or trusts something it should treat with suspicion. Those are differences between intended behavior and real behavior, and debugging helps make that gap visible. For example, an application may appear to enforce role-based access correctly until a carefully crafted request shows that a lower privilege user can still reach a restricted function. Without debugging tools, the analyst might only see an odd response. With them, the analyst can trace how the request was processed, what checks were skipped, and which backend action was allowed. That deeper comparison is what turns a confusing symptom into a meaningful security explanation. Strong analysts build a habit of asking what the system was supposed to do, what it actually did, and what evidence explains the difference. Another reason these tools matter is that many vulnerabilities today involve multi-step workflows rather than a single obvious failure. An issue may depend on authentication state, parameter sequencing, session handling, data transformation, background services, or role changes that occur across several stages rather than in one dramatic moment. Debugging tools help analysts follow the full chain instead of treating each step as unrelated. That is important because a vulnerability may look harmless if you examine only one request or one screen, while the real weakness appears only when several actions are combined in the right order. A good debugging process allows the analyst to track those transitions and understand how earlier steps create conditions that later steps exploit. For a brand new learner, this is an important shift in perspective because it shows that many real weaknesses are not single snapshots. They are sequences, and sequences are much easier to understand when you have tools that preserve timing, state, and cause and effect relationships. Good debugging also improves communication, which is one of the quieter but more important parts of a vulnerability analyst's role. Developers, administrators, application owners, and managers are much more likely to act on a finding when the analyst can explain it clearly and support it with observable behavior. A vague statement that something seems vulnerable is often less useful than a clear explanation that a certain request caused an unexpected backend action, that the logs showed a failed authorization check was never performed, or that the browser exposed sensitive data in a place where it should not have appeared. Debugging tools help create that explanatory chain. They make it easier to show how the finding was observed, what parts of the system were involved, and why the conclusion is reasonable. This matters because remediation is often a collaborative process, and collaboration works much better when the evidence is understandable. A strong analyst, therefore, uses debugging not only to satisfy curiosity, but also to produce explanations that other teams can trust and act on. At the same time, vulnerability analysts need to use debugging tools carefully and ethically. These tools can reveal detailed system behavior, sensitive data, internal logic, and operational conditions that must be handled responsibly. An analyst who is authorized to investigate a weakness still needs to think about scope, privacy, operational safety, and the difference between structured validation and careless interference. Some debugging actions may affect performance, alter state, trigger alerts, or expose information that should be viewed only by approved personnel. That does not mean the tools are dangerous by nature, but it does mean the analyst must apply discipline and judgment while using them. For beginners, this is a valuable reminder that technical visibility comes with professional responsibility. Security work is not just about how much you can uncover. It is also about how carefully you uncover it, how well you protect what you learn, and how appropriately you use that knowledge inside the boundaries of your role. Over time, what makes someone effective with debugging tools is less about memorizing a giant list of products and more about building a debugging mindset. That mindset is curious but not reckless, skeptical but not cynical, and patient enough to follow evidence instead of jumping to conclusions too early. Good analysts learn to ask what changed, what can be repeated, what the logs say, what the network shows, what the application reveals, and what internal behavior explains the result. They also learn that no single debugging tool shows the whole truth, which is why strong analysis usually comes from combining multiple views of the same event. A browser view, a traffic view, a log view, and a process view may each show only part of the story, but together they can make the real cause much clearer. That layered approach is one of the most useful habits a new learner can develop, because modern vulnerabilities often hide in the spaces between components rather than neatly inside one tool's perspective. The main takeaway is that debugging tools help vulnerability analysts move from surface-level findings to evidence-based understanding. They support validation, reproducibility, traffic analysis, log review, process visibility, configuration observation, and clearer explanation of why a suspected weakness is real or not real in the way it first appeared. That makes them essential not because they are glamorous, but because they help analysts answer the questions that matter most after a scan, alert, or suspicious behavior is observed. A vulnerability program that finds issues but cannot explain them will always struggle to prioritize and remediate effectively, while a program that uses debugging well becomes more accurate, more credible, and more useful to the organization as a whole. Once you understand that, the value of debugging tools becomes obvious. They are not side equipment for specialists alone. They are a core part of how serious analysts turn technical signals into clear security knowledge and better defensive decisions.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.